Hey, hello, look, it's time for the show. It's John Park's Workshop. It's right there. That's John Park's Workshop. John Park. That's you. Welcome. Thanks for joining. And when I say thank you for joining, I'm talking about, well, everyone watching the show and everyone in our chats. So if you're somewhere that doesn't seem to have a chat, check this one out. This is our Discord. You can go to adafruit.it/Discord. Hop into the live broadcast chat channel. That's the one that's right there. That's where people are hanging out. We've got the likes of, hey, whoa, look, all these people. We got C. Grover, Paul Cutler, hello, hello. Andy Calloway, sup. Thin Man, some nice with the square waves. Mike P, wave, hello. And Todd Bot. This is where all the cool kids are. And over on our YouTube chat, keeping an eye, we've got Dave Odessa, Charles Burniford, Dave Barry, hello. Thanks for hopping on to the chats during the show. And let's do this thing. So what's happening? This is the workshop show. I'm here. I've got coupon code for you. I've got a product pick of the week wrap up, 1 minute version. Hi, Starman. We've got a CircuitPython Parsec for you here today. And I've got a cool retro toy gear report kind of thing to show you, a weird new thing that I could not resist getting at a thrift shop the other day. Why do I do these things? You'll laugh. And what else? A project. I've got the continuation of the Servo Tester project, which I'm now calling Servo Commander 2. You can see the name right there, Servo Commander 2. It's the continuation of the Servo project. Show you where that's at, where it's going. And I'll be putting together a learn guide for that. Oh, and also do a little bit of a learn guide recap. So let me set that up just real quick so I remember. And that is for our 555 timer breakout fan dummy guide page. Yeah, we'll check that out. So to start with all of these great promises, yes, it's hidden in a mysterious black bag. You're right. What could it be? It's a tamarack bag. That's sort of a hint, but a bit of a red herring, I think. That's my little retro project or product thing. But to start off with, I've got a coupon code. That's it right now. Round will get you 10% off in the Adafruit store. So head right over here. This is the Adafruit store. You just go to adafruit.com and boom, you are automatically in the store. You don't even have to walk through a door. There you are. And you can see things like some new products that are called out right there at the front. You can click on a link here, view all new products to dive deeper, or you can hover over this up here at the top, products that will take you to categories, that will take you to the aforementioned new products. You can also go to featured products, check out some stuff there. Anything you want to get, throw it in your cart, and on checkout, don't forget that right there, because that is your key, your secret code. It's only for you for today until midnight. That will get you 10% off, and it's only good on things. So you can't use that on software, gift certificates, or subscriptions, but you can get actual stuff by using the coupon code ROUND. Round. Glad I didn't dump water onto the keyboard doing that. A little stunt. So that'll do it for you for today. So we have these coupon codes a couple times a week, usually good for the day. So that's the one you want to use today, round. Next up, let's do a little recap of this. So my Tuesday show is the product pick of the week show, and I have this little cereal to keyboard thing. If you're wondering about the silly graphic there, it's sort of a box of cereal with a keyboard. Not the right kind of keyboard, but there are time constraints. But during that show, I show you a new product pick, and we give you a deep discount on it. That's good just during the show. In that case, you don't need a coupon code. Just buy the thing, and you'll get it for a discount, up to 50% off. Here is this week's recap. CH9328 UART to HID keyboard breakout. Here is a Raspberry Pi 400. That purple cable, that's the USB output from our breakout going into the iPad. Upper right corner of the screen there, that is this Raspberry Pi right here. Just typing on the Raspberry Pi, nothing happening on the iPad, but I'm going to go ahead and run this program, sudo python code.py. And now it says listening for keyboard inputs, press escape to exit. So now this is going to send keys to my iPad. So that is the route, right? Out of the Raspberry Pi serial to our little breakout, and then USB going into whatever wants a USB keyboard. The CH9328 UART to HID keyboard breakout. Wow, thank you. No sound. Thanks everyone for pointing that out. I just kind of, yeah. I blame Lars. So yeah, all I wanted to say was, yeah, did you get one, and what are you going to do with it? I'd love to see if people are doing some interesting terminal, old school terminals or other serial sources that can send out to the CH9328 and then have it act as a USB keyboard. Could be some interesting stuff with that. All right, can you send serial off of a iPhone or an Android? I bet an Android can, with the right output dongle-y thingy. Hey, we've got other people joining us in the chat. Hello, Mondo5, who says, hi, everyone. Hi, thanks for joining. And yes, Charles Burniford, David Essa, thank you for letting me know my sound is off. Also, Andy Calloway, Mike P, Todd, Starman. Okay, whew, sound is back. That was just user error. All right, next up, let's do the CircuitPython Parsec. Okay, I've got audio and everything, so I'm ready for the CircuitPython Parsec today. I just wanted to show you how to hook up the seed round display to your QT Py and use it inside of CircuitPython. So this is a really cool new display from Seed, designed for the Xiao, but the CircuitPy is compatible. It has a lot of neat features, particularly this round TFT display here. Now, it uses a particular chip, and it has a particular pinout which are not readily available or obvious on the internet. So I did a little bit of searching around, and I came up with a formula that worked. In fact, someone in the Adafruit forums pointed out the pinout that would work for this, and I might create a little document for it that makes it a little easier to find. But here's how this works. So you can see I've got some sample code that is the GC9A01. That's the driver chip. Hello circles.py example from ToddBot, who was fooling around with these kinds of displays a few years ago. You can see this is from 2021. And I've got this running with a CircuitPy RP2040. Now, the original pinout that Todd had used is still listed here for the CircuitPy RP2040. He also had code to take care of some other CircuitPys, but since that's the one I'm using, I just left that code in there. And this is just simply a case of it is hardwired on this display because you push the little CircuitPy right down into the headers there, and you've got to use the pins that they want you to use. So here they are. For the TFT DC, we use pin A3, for the chip select A1, and for the backlight it is TX. Now those pins can go by other names, but I stuck with this convention here since those are the names that are on the silk screen on the CircuitPy. And then the rest of this code here, you can see we've got the SPI set up on the TFT clock and TFT MOSI, and then we're using the 4-wire display I/O display bus using those pins that have been selected there. And I'm using no reset, so you can see that's just set to none. And then we have the setup of the board. Display equals GC9A01, GC9A01 display bus, and then the width and height, even though it's not a square, it pretends sort of like it's a square 240 by 240. And then we use the modern display I/O group, display root group equals main to set up that display. And then the rest of this is just some cool code that Todd came up with to use essentially a sine and a cosine for X and Y so that we could move this little text object in a circle very neatly, as well as create some other little circles that are moving around with some randomized positions and randomized colors. And so that is how you can use a CircuitPy RP2040 with the Xiao round display from Seed Studios. And that is your CircuitPython Parsec, Parsec, Parsec. CircuitPython Yes, yes, indeed. And in fact, to give credit where credit is due, I'm going to go to the Adafruit forums and see if I can find that link. 1 second. That I used to find those pinouts that someone had so graciously posted. And you can sort of piece this together from the Seed Studio page on the board as well. So this, a different screen there. This is the Seed Getting Started guide, and this is linked from the product page for this display, from the Adafruit product page. And this gives you a bunch of info. Pinout or hardware overview here is nice, but what it's kind of missing at the moment is a pinout that just says which of these pins for a Xiao or a CircuitPy are going to be used hardwired to the display driver. Let me see. I've got a link I'm looking for in the forums. And, oh, here it is. If it loads. There we go. Yeah, so this was in the Adafruit CircuitPython forum, and this is by DJ AIRJR, DJ Air Jr., maybe. And they were very kind to just post not a question, but here's the answer that someone might search for later using Seed Studio Round Display for Xiao. Managed to, and they called out some of Todd's CircuitPython examples there for that display driver. and then figured out the pinout you needed. They chose to use the D digital names. I just changed those over to the same pin names that are on the board, so you can look at the silk screen and know what you're working with. So I might make a little diagram, quick little diagram that makes that easier for people to look at, and then match it up to other boards. If you have different Qt Pies, you may be picking different pin names, although a lot of those are pretty consistent. So yeah, thank you to DJ Air Jr. as well as Toddbot for these examples that include. In fact, let me show you some of the other ones. There's one, he used a photo of our good friend Lars there. There's a nice little dial gauge. So if I drop back over to my examples here, let me open up, here's the gauge code. I'm just going to resave that. Very bright. Let me dim that. There you go. I don't have a potentiometer or anything hooked up to, it's meant to read the analog pin there, so it's just going to sit there at 0 and kind of blink at us. And then another one is the little slideshow example. Let's resave as code.py. And that is a cat. It's a nice screen. Has pretty good viewing angles. There's a Lars. Neat board. In fact, if I dim or bring back the exposure on here, you can see some of the things you have access to with this board. It has a on-off switch for the display, so that does not turn off the Qt Py. Qt Py is still up and running, but that turns off the display. And I can, if I want, I'll go ahead and unplug. There is a battery connector there for a LiPo. There's also a real-time clock battery there that you can, if you're using the real-time clock, there's a real-time clock on board. There is a connector here, mysterious connector. I don't know what that one's for, actually. I haven't looked into it, but some sort of a flat ribbon connector for accessories of some kind. And there are also some mounting threaded inserts on here, standoffs. I think those are M2. I'm guessing those are M2. They look pretty small. But nice board. Just to finish up, here is what that board looks like on the store. Round touch screen there. So here you can see are these links that I mentioned to the, there's another library I haven't used that link goes to, and there's some links down here to the Getting Started guide on Seed, which is where we were looking before. Oh yeah, it also has a, let's see, it's got battery charging on here, the real-time clock, TF card slot. That's what this expandable memory slot is, I see. This little funny metal clip there. I've never encountered that, so I don't know what TF memory is, but what plugs into there? That's interesting. So there you go. Go check it out. Is there an SD card slot? Is that what they're saying with that? I don't know what they're saying. Is that a micro SD? Could it be? Let's look. Could this be? Do I have a micro? Here we go. Here's one. Are you a weird little? Oh my gosh, it is. It is. Ah, that's a neat little minimalist SD slot. I did not know. There's no fancy springs and things in there, but it is indeed. Thanks for the tip there in the chat. Yeah, that's a little SD slot. Ow, cool. All right, looking forward to doing more with these. Very nice. It's a flavor of SD card. Yeah, weird. I never heard a TF card. What matter of thing is that? Wild. Okay, so that is that segment. That is our CircuitPython Parsec. I'm going to set that demo off to the side. Next up, what have we got going on here? Let's, since I just showed it, I didn't mean for that to be a product pitch for that little cool display. I just wanted to show how it works, but that's the coupon code because of that round display. You can buy anything you want with it, but that'll get you 10% off. If you want to grab one of those, go ahead. And next up, let's talk about this mystery thingy. What is that? What could that be? What's in there? Let's go find out. All right, you can step away, Lars. Go hang out, play Pac-Man. So this right here is a thrift store find from last week. I think just like a week ago exactly, maybe. I think on Thursday, I was at a thrift shop, as I'm wont to do, and I saw two interesting gizmos side by side. Turns out they go together. So first of all, nice big Tamarack bag. This is a camera bag company. I don't know if they make other stuff, but they're well known since probably the 70s for doing high quality bags for your cameras. So that's nice on its own, and some of its contents were related to the thing sitting next to it on the shelf. Turns out they go together. And that is, I'll show you some of the other stuff in the bag later, but that is what caught my eye at first in the bag next to it. What is a Panasonic AV watch? What the heck could that be? I said, and they only wanted $25 for it, so I said, that's whatever that is, I need that for $25 because, come on, look at it. It's got a little carry handle. It's got a nice carry strap on it, Panasonic branded. It says AV watch here. Product number on the back, it says PVM429. So it says it's a video product, okay. There is some encouraging stuff on the side here for a video product. We've got RCA jack in for audio and video, RCA jack out for audio and video, a DC 12 volt in, that's nice. I'll tell you one thing, when you are hunting weird old gear, it's encouraging when the power input is something fairly straightforward like DC 12 volt. Sometimes you'll find weird things like AC that you have to get less common adapters for, but this is a 12 volt DC, and I don't think it mentions polarity on here, but in the bag it actually came with the power recharger adapter that can be used to charge batteries or charge power this directly. And there's an audio out here. It's a stereo, I'm assuming stereo earphone out. I haven't tried it. There's some latches for opening the lid on there, and this is the battery case. It takes a dry cell battery that it happened to come with. I don't think that the ones that it came with it take a charge anymore, but I think people still make this kind of battery because it was common in a lot of Panasonic VCR or videotape recorders, and I guess people still use those enough that you can buy those. And here's what we see when we open this up. Dun dun dun. It is a VHS tape player, recorder, and 4-inch LCD. Wild, right? So I'm just going to open my Discord on here in case there's any thoughts, questions, gasps, screams. I don't want to miss any of that. Or if anyone's used these, knows things about them, has opinions, I always am interested to hear. Let's go to live broadcast chat. Here we are. Sorry, I just need to set my phone to not go to sleep. Okay. So you can't do much without power to it. It won't open the deck. But this is a full-size VHS deck. It has play, rewind, fast forward, search in both directions, pause. It has a record function, so whatever is coming in, you could record directly to tape here. So that could be any source you want. You could record another VCR for dubbing, a console off of TV through a tuner, a camcorder, etc. Power button here, and then these, zoom in a little bit more. These are some of the VHS controls tracking. Just if you have lines and misalignment of the signal, you can fix the vertical. I think it's usually the vertical tracking of the tape with these buttons. Speeds for recording: slow, long, and super long. I think that's what it is, or short, long, and super long. And that determines how fast it moves the tape. So you can either fit more on the tape or get higher quality. Not even mini VHS, that's right. It's not like a VHS-C. It's the full-scale thing. And there's a counter, reset, and recall. And then up on the screen here, we've got some dials for tuning the color, tint, brightness, and volume. There's a speaker here, and I'm assuming that also applies to the audio out there. So let's see what we get if we give this thing some power. In fact, let's take a look at our goodies in the bag. If we open this up, we have a couple of these big honkin' batteries. They weigh a ton. These are 12 volt, 2.3 amp hour batteries. And we have a 12 volt adapter for the car, so you could use this off a cigarette lighter car, 12 volt adapter. And then inside of another bag, and this bag is in nice condition. $25 just for the bag alone is actually, I was like, okay, this is worth it. And the fact that we've got all this wacky gear as well, like I say, I can't help myself. So this is the combination battery charger and power adapter for the player. So we've got, I'm just going to plug this into an AC outlet. And now you can see this says it's got power. And we actually have a selector switch for, is it trying to power the player or is it trying to charge a battery? So we'll flip that to power, and then it has the barrel, DC barrel output. So that's what goes into power of the player. And you can see I can power it up. We have a screen. That's encouraging. We can press stop eject, and it actually opens up the VCR, and that is one compact little VHS. I mean, if you've opened VCRs before, there was a lot of empty space generally, so it's not super miniaturized or anything. I see a lot of surface mount. I haven't opened this up yet, but I see a lot of surface mount components in there on the controller board in the back. You know, nothing obviously broken or jingling around in there. Everything seems to at least be in place. If I will cut to the chase. If I try to play a tape on here, it's failed every time on me. So it makes some noises like it's loading the tape, and then it shuts the whole thing down. So sorry to spoil that, but that's what's going to happen here. So here we've got a trusty copy of the Terminator. I see it spinning. It's spinning, it's stopping, it's spinning, it's stopping. I think it tried to autoplay. It just shut off. So yeah, I think this one has the write protection tab removed, so that usually tells the player just to automatically play. So I can turn it back on, hit play, and you might be able to see that there. It's trying to spin it, which means, you know, there are some belts that are actually still sort of connected. They may just be loose and slipping. We'll see. But that's the sad state of it with a VHS tape. Now, if I'll go ahead and eject this. That works, which is, again, nice. The thing is in clean. I mean, it's real clean. I think someone took care of this. Neat thing is the input does work. So if I grab a source, let's see, I've got a Nintendo NES over here that's plugged in. If I grab a composite video source, this yellow one here, and actually I can give it audio as well, which I'm just going to do mono over the white one. So if I plug these in and turn on my Nintendo, which needs power, you can see it's up and running. Let me get the glare off of there. It's actually a pretty decent little screen, which is exciting. It does not, the lid only opens this far, so to have this camera see it, I've got to stack some things there so it'll stay where you can see it a little better. And then I can grab a NES controller. Boop. There we go. Color is a bit cranked up. Turn up the volume. That's decent, right? My white balance on this camera is a little screwy, so it's warming everything up a lot more than it is. Can I tint it down? Oh, yeah, I can kind of artificially force that to bluer. That's about as good as that's going to look. And there you can see we got a little speaker built onto it too. So obviously I did not get this for the screen. I've got better screens and I like playing those on CRTs. But if I can get this working, it's a pretty neat player, and especially for people who hunt for VHS tapes. I know a guy who runs a little VHS rental store that only opened just a couple years ago. These kinds of things are probably pretty neat if you have the battery in there and you can just carry that on your shoulder and go to flea markets and stuff like that. If you want to pop a tape in and see what's on it, especially people who buy mystery tapes, kind of neat, and could also just act as a straight up player for any TV that you plug the output there through. I don't know if it acts as a through. It may. I haven't tried that yet. So with the NES coming into here, can I also send the output to a TV? Just to probably you can, and that way you can record stuff onto here while you're watching it on a full size screen instead of just this little LCD. But yeah, that's the weird thrift store find. I may take a, yeah, it is a great, somebody says it's a great CyberDeck candidate. If these things were common and cheap, I would pick a second one up on eBay and build a computer into there or something, because that is pretty darn neat. They are actually, I have only seen one on eBay that someone is optimistically asking for over $500 for. I don't know if anyone has ever sold one for that lately. I believe when these came out, this one came out in 1991. I think they ran up until 94, 95 or something like that, maybe longer. These were in the $1,300, $1,400 range. I think this was one of the premium portables. There were a couple brands that did some little portable VHS machines, and this was among the nicer ones. So I don't want to dig the guts out of this one yet. I'll show you the little battery slot. Pretty cool. This goes in here. There's a big spring-loaded ka-chunk, and now that's there. I don't think there's juice. Yeah, it doesn't want to turn on with that battery, but could be worth seeing about getting a third-party replacement. They are out there, and this has a nice big eject button there for the battery. So there you have it. That was there's a story behind this. Someone needed this for something, I guess. Wild. All right. So that is the retro gizmo of the week there. I'll put it back into its lovely little case here. If you have a love of VCRs or VCR stories, share them with us. I'd love to know. I've been doing stuff with VCRs forever and ever. I don't know if any of you ever saw the PBS Make Magazine show that I hosted, Make Television, but we did one of the sort of the most famous early Make Magazine projects was a cat feeder that was rebuilt from a VCR. So when the VCR's alarm was set to go off at a certain time, it would spin the motor, and that would cause cat food to come out of a little hopper. That was one of the early Make projects that we had to do on the show. And I've been goofing around with VCRs on and off ever since. This is the latest in a long line, so we'll see what comes of that. There was a time when I had a lot of VCRs in my workshop too. They are all but gone. I think I have one CRT with a built-in player that is terrible. It needs a lot of weight. It actually does play, but the colors on it and tracking and stuff are pretty bad. But yeah, now I got this one. We'll see what happens. Okay, next up, let's do a little, I mentioned I'd do a little Learn Guide recap. So this was the PC fan dummy that I did as sort of a product. It was both a product pick of the week and a project add-on, kind of all in one. So this is the 555 PWM output stemma. I have one right here. It has a little 3-pin stemma PH connector on it, so you can get these convenient little cables. And that means without even soldering anything onto there, you can get power ground and a square wave signal, 555 square wave signal coming off of this. I think I may end up using this to show some oscilloscope stuff. I'm going to start doing some little basics of using the oscilloscope as I try to increase my knowledge of my oscilloscope and how to do stuff with it. That'll be a decent one to show capturing the frequency and voltage of a wave, and being able to adjust that on there is kind of nice. So that's kind of an all-in-one, the whole circuit you need to send out a square wave that you can adjust the frequency of. And the original request that Lady Ada had was to make a fan dummy for a PC. So if you have a PC and you want to remove the big honkin' fan that is this fan cooler here on top of the CPU, or other, there's usually little chip cooling. You can see some fins there on this graphic card. So those you can replace with water cooling or oil cooling, other liquid cooling that have a much quieter pump than the spinning fan that's moving a bunch of air around, and they circulate a liquid to a radiator, cools off, grabs heat, cools off. But your motherboard sometimes gets mad about the fans being unplugged, and so in some cases your BIOS won't let you disable alarms and things. It kind of won't let it get through the power on self-test or post of the BIOS. And so people have come up with solutions using 555 timers to fake out the tachometer that is built into the fan headers on a motherboard. So a lot of the motherboards have 4-pin fan headers that give you power, ground, a signal reading coming off of a Hall effect sensor on the fan, so it's just pulsing 5 volts every time it spins. And then some of them will have a fan speed output so that the motherboard can adjust that fan speed. So this can just plug in instead of that fan. It powers the chip and it gives it the signal that it's looking for. The motherboard gets the signal it's looking for. So I just documented this with some stills, and I also have the video from when I showed this in action. Here you can see the BIOS gets mad when we have a fan unplugged. You see current system fan speed is 0. Then it started alarming and being mad. So I plugged this in instead, and you can see there's my system fan ground, power, and signal from the left to right there in that image. And that's telling the little 555 timer breakout, giving it power, and then receiving the signal it sends. And then the breakout has a selector switch for ranges of speeds. So we'll go to the slower range, and then we can crank it anywhere from, I forget the lowest, maybe 600 or 800 hertz up to, I think, around 8,000 on that one. So you can see here I've told it that it has a fan running at 8,544 RPM is what it thinks, and that's just because I'm using the little trimmer pot there to adjust the speed. And that's it. So that's the whole page. Just shows you how to do it. No code involved. It's just a plug and play thing. You just got to get your pinout right. Your motherboard, there's a fairly standard pinout, but your motherboard manual will tell you what those order of pins are. In this case, I did not disconnect the CPU fans because that thing was up and running, and I did not want to cook the thing. So it was just one small case fan the system fan was connected to, which by having this open and not really doing much, I felt was safe. But there you go. That's that'll, I think, let you know one way to use this, and there's of course millions of other uses for a 555 timer, but that'll take you through that, and you can check that out in the Learn Guides. If you head to learn.adafruit.com, you can go to this New Guides section and then click View All, and this should have the top 20 or so most recent guides that we've created. Here on the first page towards the bottom is that 555 output one. So Liz is just killing it with these product ones. Thank you so much, Liz, for doing all these product guides. It really gives you what you need to get up and running. And then of course we have some cool project guides inside here as well, and updated guides that have been around but needed some refreshes to them. Okay. Next up, last thing I wanted to do was I'm just noticing the YouTube chat. Wanted to see if there's any comments in there. DJ Morph said, nice old school portable capture unit. Yeah, the cables are in good condition too. You're right. I was just looking at the power charger. All that stuff is clean. Someone either didn't use it much or took really good care of it. DJ Morph also asks, what is that thing? That is Lars. Yeah, he's a scary sloth. He's a friend of the show. David asked about the manufacture date for the VCR. I might have mentioned that. It was 1991. Maybe the heads need cleaning. Absolutely good. Yeah, I've definitely got to get in there and clean that. DJ Morph says Akai made nice VCRs back in the day. I did not know that. I don't think I've ever seen Akai VCRs. Neat. Okay, so last thing I've got for today is grab it from over here. What am I calling this now? The Servo Commander 2. So this is a Perma-Proto board. On it, I have a Feather reverse TFT ESP32S2. So that's a Feather, and I can pull it off of here. It's just on some header pins. Yeah, oh, it's got a battery on it too. So it's going to turn itself on now. The feather, normal feather stuff and pinout is this side. This is like the bottom of the feather that has that TFT screen on it, which is nice. It means it can be a bigger TFT screen than when we fit it on the sort of normal front side. It also gives us room for some buttons here, which I'll use for an interface. So you can see I've got a little LiPo battery that just powers the feather. I'm going to stop showing it that way and put it in the overhead because that's what the overhead's for. Let me give you this view. We'll pull out in a second to show more of the project, but I'm going to zoom in tight to show its components first. So here you can see I've got a 4 AA battery pack that has a little on-off switch on it. This is a decent way to power the servo motors. They want about 6 volts. Better is a 5 or 6 volts is I have a 5 volt, 4 amp power supply plugged into the wall that I can use. But this is good if you need it portable. The whole thing is portable since the feather can run off of the LiPo battery. And I've got a little slide switch here that's connected to the enable pin on the feather, so that turns the feather on, but of course we still need to turn power on the battery pack. So now that's powering, the battery pack is powering the servo, LiPo is powering the feather. The feather TFT is giving me some information readout there that we'll look at more in a second. And then on the PermaProto, I've just run 2 rotary encoders, and they each have a couple of ground connections. Really only need one. I think you could bridge the internal ones, but this is essentially a switch, the 2 pins here. I happen to sort of flip these upside down from normal order, I think, partly to make the wiring a little easier. I had more access to the pins on top the way I laid it out. But we've got a ground and a push button, so these are push encoders, you can click them. There's a pin, this orange wire is going to for reading that switch. There's a second one over here doing the same thing. And then on the top there's, again, ground running to a ground rail. All the grounds are joined on both sides of that PermaProto there. And then there's 2 pins being read with PWM I/O. So this is all CircuitPython. There's 2 pins per encoder that read when those essentially contacts get clicked, and that's how you can read the direction and number of turns on the encoder. So a pair of pins per are going up there. And then I'm running a PWM output to the yellow wire on each of these servo connectors here. Let me pull this view down, and I can unplug my servos. You can see here I've just got header pins, and I got a little fancy and snapped off, I used extra long headers and I snapped off some colored header pin shrouds so that I could color code those for the orientation. That's basically the same as what a common servo is. Common servo usually uses brown for ground, orange for power, and yellow for the signal. So those correspond to my ground, battery power from the alkaline AA's, and then the PWM output for servo control. So hook those up. You can hook up any common hobby servos. And then if we look at, oh, thank you, Anisku7 said, nice wiring, thank you. I tried to keep it pretty neat so it would be easy to follow in the guide. So if we look at the display here, and I'm going to adjust my exposure for a moment so that's easier to read, you can see I've got right now, just a simply informational readout at the top there that tells me what the pulse length range is, so the shortest to the longest for these servos. 600 to 2400 is one of the common ranges you find. 800 to 2200 will be a little narrower range, but this basically says how far off center can the servo motor turn. One of my servos, just for manufacturing reasons I guess, was acting a little twitchy if I gave it 2400, so I backed off of that until it behaved better, which happened to be 2300. So that's why you'll see a different number up here on the top. So this is meant to be, pulling out a bigger view here, this is meant to be a sort of test bed for your servo motors, as well as a way to come up with values you want to use in your code, or just to pre-program an animation of some kind. Could be for an animatronic thing, could be for a robotics thing. And so you can see if I turn either of these encoders, I'll change the angle on one of the two servos. These are little micro servos, but they look basically like these kind of servos here. They're just smaller ones. These will work as well. I could just plug these in. In fact, let's do that. So if I take this, just because the pan tilt gimbal, and thank you Some Nice, I think last week you reminded me what the name for those things are. So the pan tilt little bracket gizmo I have there is just two servos, one acting as the pan and one acting, a second one as the tilt, and they're coupled. But here's, if you just need to test two, they could be connected to anything. They don't have to be paired up like those are. So here you can see if these will stay put, stay. So this is turning that one on the right, and this is turning that one on the left. Now, as I'm doing this, let's try to get the screen to be a little tighter in. By the way, you can see also I've got one of these aluminum swirly grids that we have to bolt things to. So I've just used M2.5 nylon hardware to hook up my permaproto, and M2 to hook up this little pan tilt gizmoid there. I'm just going to goose the exposure a little bit more. So what you should see is the readout tells me the angle. So this one should go from, in this case, I clamped it at 8, and in the other direction, I think I clamped it at 172. Is that right? Yeah. I think maybe it's the same on this one as well. So those are the sort of live, real-time settings. So you can, if you have this hooked up to sort of an animatronic kind of thing or robotics thing, you can just say, okay, what we need right now is to get to this position. You turn this and you just write that down. Okay, 114, that's the number. You put that in code. I've also got 3 saved positions per servo. So on the screen here you can see it says D0, and these are just corresponding to these buttons. They happen to be at digital pin 0, 1, and 2, so D0, D1, D2. So my D0 position right now is 8. So if I press that, it's going to send both servos to their far right position of 8. If I press the middle one, that goes to about 82, which is roughly the center of these based on their range. And then if I press the last one, they'll go to their far left. I can then adjust one of these, and you'll see the real-time display at the top. And then I can overwrite the saved positions. So if I click this encoder and press the D2 button, you'll see it just changed to store that value. So here's my saved value. So I have an 8 on this servo, and I have a 172 on this servo. So that means if I press the D2 button, they'll point towards each other. So now both of them are pointing in. If I press the top button, they're both going to go far right. Middle is the middle. Right? So this will actually be much more fun with the pan tilt, because we can animate little coordinated moves with them. So I'm going to plug those back in. And now if I want to set my sort of starting position here, and you know what, before I go any further, I'm going to plug in my power supply so I'm not just running off of those alkaline batteries. I don't want those to get weak and die or anything like that. Okay, so this is running off of a wall 5 volt. You can see they're still doing their thing. So let's go and set up a little animation. So we'll start, how about right in the middle with that. I just put some tape on here so we could see this a little better. So we'll start in this position. So this is our first frame of an animation, say. So I'll store the left servo, which is this bottom one with the blue tape, as position D0, and the right one, same thing. So those are now stored as that first position. Now let's say we want to turn to the left, and I'm running into my battery pack a little. Let me move that wire. Say we want to turn to the left here and point down just a little bit. So again, I'm going to store that as the first servo position D1 and the second servo position D1. Okay, so now if I go back, that's the first position, that's the second position, and then let's set the third position. It'll be far right and tilted all the way down. I'll store it. I'll store it. So now we've got these three sets of positions. There's 1, there's 2, there's 3. 1, 2, 3, and we can just play those back in any order. Or we can cycle through them like they're a little animation by clicking both buttons. So I set this up so that if both of these are pressed, it will just play back each position with a little, I think, 3/4 second pause between the first two and a second pause after the last one. 1, 2, 3, 1, 2, 3, 1, 2, 3, and when I let go, that'll stop doing that. And you can always readjust these to anything you want. Resave, resave, and now it's gonna 1, 2, 3, 1, 2, 3. And there you go. So the next step on this I want to do is add some smooth animation. Right now it is setting the servo to get to its new position as fast as it physically can. So I'm just sending it essentially directly. So the in this case, the bottom servo here, the one on the left, is going to go to 88, then it's going to go to 115, 122, and those are just as fast as it can. If we want it to take its time to do that, or even ease into it or ease out of its motion, I'm going to set up some little loops in there that will do the current position, the position it's trying to head to as a little loop, and it'll iterate through 1 degree increments with some timing so that it can get there a little more casually. That's a nice thing to add to servo motion, because a lot of times we're used to servos just trying to get there as fast as they possibly can, but it's nice to see things that can move with some more organic qualities to them. So that's something I want to add. And then, like I alluded to, the other thing I want to add is some of these settings, like the pulse minimum and maximum length. You're often tuning those in code to get them to match up with your physical servo. So it might be nice to be able to go into a mode with a button combo where we can have it just sweeping back and forth between some extents and adjust that timing till we like it, and then stamp that down and save it. So last thing we'll do is just take a look at the code for this as it is right now. Let me bring up my code window, and don't save that, don't save that, don't save that. Let's open. I gotta plug this in. Okay, so this is all running CircuitPython, and here's what's happening. Oh, that's not, in the chat, someone nice just said they found a handy website called easings.net. And thanks for bringing this up. Someone else brought this up to me recently too. Todd Kurt mentioned this just earlier today. Let me jump over here for a second. This is a website with easing functions that you can use in your code to do different types of non-linear motion. So if you want to slowly get up to speed and slowly come out, then you'd want something like this maybe this ease out exponential function here, which is you can see that the type of motion is highlighted as you hover over it. With that little vertical move there. Really nice. So these are typical in things like animation and animatronics to, oh, these are weird ones down at the bottom. Oh, here's a ball bounce, boing, boing, boing. To give things a nicer motion instead of just get to point A to point B with equal spacing in timing. Thanks for pointing that out so nice. I think that'll come in really handy. Very nice. So here is the code that I have right now. I've got, I'll gloss over some parts of it, but touch on what I think is the interesting stuff. So first of all, I'm using rotary I/O to read these two encoders, rotary encoders. I'm using PWM I/O to send out the servo position signals. And am I? I think so, or is that, I can't remember. We'll look in the code. PWM I/O has some overlap with rotary I/O and with Adafruit motor servo, which is kind of like a high-level library for the servo stuff. I'm using keypad for reading the buttons, just because that makes it easier. Here's some of my to-do list to myself. Right now the code is very non-optimized, so you'll see some cut and paste of like the same thing 3 times that can probably be turned into functions. Oh, and I did playback, so I can scratch that off the list. So here you can see I'm defining these minimum and maximum pulse durations, as well as my minimum and maximum angles. And those were the ones that I want to be able to maybe tune, maybe all of these tune in the interface. Okay, yeah, so PWM I/O is being used for the output, and I have 2 pins, pins 10 and 11, that are being used for the 2 servo outputs. Frequency of 50, this is really common on hobby servos, but it could be something that you also expose so that if you plug in weirdo servos, you can adjust what that PWM frequency is. Then I'm setting up servo motors using the servo object in the servo library, or motor library. PWM1, PWM2, servo 1, servo 2. This is my current playback thing. It just is real simple. You can see this is where I'll be able to add things like ease in or ease out, or both. It's just saying go to the angle that's saved in slot 1 for both motors, pause, go to the next save slot, pause, go to the third save slot. So that function gets called when I press the 2 encoder buttons. Next, you can see I'm just setting up 2 rotary encoders, and I start them out at 90, and I also start out the servo at 90. Actually, I don't think I'm specifying where they go on wake up. I think I let them just stay where they were instead of immediately jumping somewhere. Setting up the buttons on the encoder so I can click those. Display setup. Gloss over that. This is all of my little, this also could be optimized, but I've just got separate little text labels for all those different pieces of UI display. I've got some state, I call modifier 1 and modifier 2, and that's just when I press an encoder, it's like a shift key or a control key or something's being held. And I test those to see should the buttons go to a position or should they record a position. Then my main loop here, I check for button events on these 2. And then if this one is pressed, I set that modifier state. If this one's pressed, I set its modifier state, and either it gets released, we set the modifier state to false. Here's how I'm doing playback. If both modifiers are pressed, then it just runs that. Got to move this battery pack. That's what happened. It slid over. Then we run that playback function the whole time that those are both pressed. That's it. You could probably turn that into a toggle if you wanted to as well. And then I do some button events. Unfortunately, the D0 button has a different pull resistor direction than Ds 1 and 2, because it's also, I think, used as the boot button for the bootloader. So I can't use keypad on those as one keypad object. They have to be separated. So this is D0 as its own thing, and then this one is D1 and D2 as their own separate keypad object and therefore keypad events. But this one checks just the 0 button. Here you can see if the modifier is pressed, then we're going to save the state for the given motor in that D0 slot. And that is just a variable, just an integer variable that gets saved right there. And I'm always setting that within the constraints of 0 to 180 or whatever my min and max are. If it's modifier 2, we do the same thing for the second motor. Otherwise, if D0 is pressed, we just recall the servo angles. And I'm also setting the encoder position. So you can see if I'm way over here on the right and I press a recall button, I don't want when I touch the encoder for it to jump all the way back to where the encoder was. So I'm actually resetting the encoder position to the servo position. So that just prevents a big jump when we touch it. I think I need to implement that in the playback as well. I don't currently, so if I do some playback and then touch a button, if I can get it to stop. Okay, let's go very far this way to demonstrate this. Now, if I do playback and stop the playback when I touch this, it jumps because the mismatch between the servo position and the encoder position. So that's a nice thing, and thank you, C. Grover. I was trying to figure this out last week and couldn't figure out. C. Grover said, oh, encoder.position equals, and you can, instead of reading it, just tell it what to be. And that takes care of all the offsets. I didn't have to do a little function for that. The other two buttons act identically. This is how I'm reading the encoders, just simply checking their position. This is to see if they have changed. Then we start adjusting the servo angles and repeat for the second one. And that is it. So that's all it's doing. It's just long right now because I have a bunch of repeated stuff, but I should be able to condense that down and add that ease function, and then we'll be able to write that up, and you can go and make a Servo Commander 2 or Servo Tester or whatever you like. So I think that's it. Let me know if there's any questions or thoughts about that. Some Nice says for control of pan tilt, I've used a single thumbstick. I can go to the Discord. There's a little link there to one of those little 2-axis thumbsticks. That's a cool. It'd be kind of nice to add that to this maybe too as a little optional add-on if you want to do some more puppeteering kind of stuff that way. Was there any remote control 3-servo project from the past? Ideally BLE, but Wi-Fi 2. Seem to remember a quick show and tell or maybe a Parsec. Yes, there was. I did, and it was years ago. And I was actually looking for the, I had 3D printed a pan tilt gizmo to connect 2 of these bigger hobby motors so they would work. I did an eyeball project with these one time, so I've done stuff with these a few times. I think one of them may have been a BLE one, but now I can't remember either, so I'll search around. RC radio transceivers make it really easy to control servos. I wonder if you could put CircuitPython in between. It's a good question. I don't know what radio stuff would be necessary, or if you could just add CircuitPython before the transmission. Good question. Oh, yeah, Toddbot says, use that cool string controller. This thing. This thing, I swear I'm going to do something with it. But yeah, these are joystick X, Y, but then there's the Z. What would that do? What would that tell the servo to do? Maybe a third servo on pull? That could be neat. Very neat. That's going to do it. So before I go, first of all, I want to thank you for stopping by. Whoa, I'm going to disappear myself. There I am. Thanks everyone for coming to the chats and for hanging out. Thank you, DJ Morph, Dave Odessa over in the YouTube, Mando5. Thank you. Sushma, hello. Sushma had asked, can it do C programming instead of CircuitPython? I don't know which where in the show you were asking about that. If it's this, I think there are Arduino drivers, so you could use Arduino for this little display. Probably also MicroPython. Yes, for this as well, ESP32S2, you could use Arduino on that, which is pretty much C programming. Hope that answers that. Thanks also to Dave Barry, Dave Odessa, Charles Berniford for hanging out in the YouTube chats. And then thanks everyone in the Discord. I won't call you out by name because I can just show you. I have that one right there. Look at all these people. Thank you. Last thing, if you want to buy some stuff in the store at a discount, use that. Round. Round is the coupon code. You could get one of these. A round display with the round coupon code. That'll get you 10% off. What have we got going on? I will wish you a happy weekend coming up here. I think we've got a deep dive with Scott tomorrow. Not sure if Foamy Guy is doing anything over the weekend, but also check for Desk of Lady Ada at various, sometimes Sunday, Lady Ada hacker times. We'll be back on Tuesday with Product Pick of the Week, Wednesday with 3D Hangouts, Show and Tell, Ask an Engineer, and more. So that's it. For Adafruit Industries, I'm John Park. This has been John Park's Workshop, and I will see you next time. Bye-bye.